today we are going to talk about lots of graphing stuff. Cool? Graphing lines mainly. You remember how to graph lines? What form are lines in?
Straight.
What is the equation for lines? Y equals what? Mx plus b. Okay, and m is my what? Slope. B is my what? Y-intercept.
Yeah.
Or y-intercept. Okay. So we're gonna just head on into this and kind of just work our way into graphing. Okay. So let's talk a little bit today on some stuff. And let me take attendance because I can't do that. So, first of all, we're going to represent relations and functions, okay? A relation is a mapping or a pairing of input values with output values. Pretty simple. It's a mapping or a pairing of input values with output values. Okay? The set of input values, or the X, is your domain. Domain and range are not going away. We're going to talk about them a lot this year. Your range is the set of output values, or your Y. Okay? Because I always input for X and I always get Y out, correct? When I graph and do things.
Yes.
Okay? So input, output. Input is domain, output is range. Okay? Meaning, it's going to ask us, how far is this going on the x-axis? How far does this go on the y-axis? Okay? So here's some examples. A table, a graph, a mapping diagram, and ordered pairs. If something is in ordered pairs, it has an x, a y, an x, a y, x, a y, x, a y. Okay? I can change those ordered pairs into a table. So -2, 2, I would have a table for x, I would have a table for y, and I would just list my x and y's. Does that make sense? I can also graph those order pairs. If I graph -2, 2, it's right there. If I graph -2, -2, it's down here. Okay, 0, 1, and 3, 1. Now, a mapping diagram, have you guys done mapping diagrams before? Where you have an input and an output, a domain and a range, okay? So I only have to list my inputs and outputs. I don't have to repeat them. I'm just going to draw arrows. So I only have to list them once. So if there are 7 5s that are inputs, I only need to list 5 once. I will draw 7 arrows to different spots. Okay? So my inputs in this case are -2, 0, and 3 because I have 2 -2s. Notice that? Okay? My outputs are -2, 2, and 1. Okay? I have 2 1s, but I only list 1. So I have a -2, I get a -2 out. I have a -2 input, I get a +2 out. I have a 0 input, 1 out. 3 input, 1 out. Okay? And that's how we're going to make mapping diagrams. Cool? You think you can handle drawing those and doing that stuff? Okay. So then we are going to consider relations. Okay? It says consider the relation given by the ordered pairs -2, -3, -1, 1, 1, 3, 2, -2, and 3, 1. Identify domain and range, and then represent the relation using a graph and a mapping diagram. First, we're going to find domain and range. What is domain again? What values does it represent? The input or my x. So what are my domains up here? Yeah, -2, -1, 1, 2, 3. I literally am just writing a list for my domains. Cool? We're not taking it any further right now. My range represents what? Outputs or my y. So what are my outputs? You were right. Keep going, Eddie. -3, 1, 3, -2, and 1. Okay? So I have a list of inputs and outputs. Once again, if they repeat, you don't have to list them a second time for domain and range. Cool? Okay. So that should be pretty easy, that part A, finding domain and range, listing numbers out. The second part wants us to represent it using a graph and using a mapping diagram. So first we're going to start with a graph right here. Okay. I just put a grid on here so that I can work with it a little bit better. Let's see here. How can I graph this? what comes first when I graph? Let's graph -2, 3, -3. Where do I go? I go, yeah, I'm gonna go, well, not down for the x-axis. Which way do I go for the x-axis? Left. So I'm gonna go left for the x-axis, and then I'm going to go down 3, right? Over 2, down 3. So 1, 2, and 3, something like this, okay? And I'm gonna go -1, +1, right? And then I'm gonna go 1, +3. And then I'm gonna go 2, where's 2? And -2. And then I'm going to go 3, 1, yes? Okay, now, when you graph for me on your homework, 1, it's much nicer when you use graph paper, hint, hint. And number 2, label things for me. If these are not 1s, if your dashes are not 1s, I need to know the difference. Like if you're counting by 2s or 5s or 10s or whatever, okay, tell me. Cool? Otherwise, if they're 1s, you can just leave them and that's fine. Represent the relation using a graph and a mapping diagram. How do I make a mapping diagram of this? I need to draw boxes. What are they labeled? Or, yeah, or what? Input and output. It's technically input and output. So I'm gonna have input, right? And I'm gonna have output. And I'm going to list all my inputs. My inputs are -2, -1, 1, 2, and 3, right? -2, -1, 1, 2, 3. Okay, now I'm putting them in descending order on purpose, or in order from least to greatest, okay? My outputs, I have a -3, a -2, right? A -3, a -2, because I want to put them in order again from least to greatest. I have a 1 and a 3, right? Okay. Now, when I have a -2, what does it match to? -3. When I have a -1, what does it match to? 1. When I have a 1, what does it match to?
No, 3.
To 3. 1 to 3. When I have a 2, -2. And when I have a 3, a 1. And that's how you're going to do those sets of directions. Sound cool so far? Easy peasy? Good, we have 8 more slides. Oh, some of them are like this though, okay? A function is a relation for which each input has exactly one output. A function only happens when each input has exactly one output. So if it has more than one output, it is not a function. Does that make sense? Okay, so a function will only have one output. If it has more than one output, if the domain or the x has more than one output, it is not a function, okay? So here I have 2 charts, inputs, outputs, inputs, outputs, okay? It says tell whether the relation is a function, explain, okay? Is A a function? What tells me if something's a function? It has one outcome. Does -3 have one outcome?
Yes.
Does -1 have one outcome?
Yes.
Does 2 have one outcome?
Yeah.
Does 4 have one outcome?
Yeah.
So is it a function? Yes. They can share an outcome, but they can only have one outcome. Okay? They can share an outcome, but they can only have one outcome. So this is a function. Over here, does -2 have one outcome? Does 1 have one outcome?
No.
So is it a function? No. It has more than one outcome.
Okay, so
This can only match to one thing over there.
gotcha.
Okay? This can match to however many it wants. Okay? Because it depends on the input. Okay? Input has to have one output. The other way we can test something, if we have a graph, is the vertical line test. Okay? Vertical line test is nice and easy. If I can draw a vertical line through the graph and it only crosses through it once, it's a function. If it crosses through it twice, it's not a function. Because watch, this input of 2 would have 2 separate outputs, a +2 and a -2. So So therefore, it's not a function because it has two outputs. In order for it to be a function, it has to have one output. I'm just gonna keep repeating that. It's gonna get really annoying. Okay? So on vertical line tests, we like when it's already graphed because I can draw a line through anything, right? Draw a vertical line and see. Makes it easy. I don't have to do any math. Okay? Word problem. The first graph below plots average points per game versus age at the end of the 2003-2004 NBA regular season for the 8 members of the Minnesota Timberwolves with the highest averages. The second graph plots average points per game versus age for one team member, Kevin Garnett. Over his first 9 seasons, are the relations shown by the graph's functions? Explain. Is this a function, is what they're asking? Is this graph a function? Why not, Annika?
It's, on the 28.
Yeah?
It has 2 dots.
Beautiful, not a function. Is Kevin Garnett's a function? Yeah, because there's exactly one output for everything. Cool? Okay. Equations into variables. Okay, many functions can be described by the equation. We talked about this, y equals 3x minus 5, better known as y equals mx plus b form, okay, with my slope and my y-intercept. The input variable in this case is x. It is the independent variable, okay? When I'm plugging stuff into something, it's the independent variable. The dependent variable is the one that I'm getting an answer for, okay? Because x is by itself, it can do what it wants, anything can go into it, but y has to depend on x for an answer, okay? So the independent variable is my x, and my y is my dependent variable, right? It's kind of like you guys as kids. In order to get things, you have to ask your parents' permission, right? Okay, so you depend on what they do, okay? That x is the parent, causing us not to do what we want. Okay, so that's one way of remembering it. The output, of course, is the y, so the y is dependent. The output is dependent on the input, okay? Graphing equations. There are 3 simple steps to graphing equations. One is construct a table of values. So on your homework, you're going to show me -2, -1, 0, 1, 2, and that you plug those numbers in and got outputs, or whatever they are, okay? So construct a table for me, show me the inputs, show me the outputs. Then you plot those points. Then you connect the dots to make a curve, a line, whatever it is. Cool? Okay, so we're gonna do some of that. So, I have y equals -2x minus 1, yeah? And we're gonna pretend that all my graphs are beautiful this year. Because you guys love me and I know it. Let's see here. Boom, 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 boom. Boom, boom, boom. Okay, and then we'll go like, we'll put a couple in here, how's that? Just to give us more. And remember, your graphs will be better because you will have graph paper. Now, what's the first step to graphing this?
Chart.
Make a chart. I suggest always plugging in 2 negatives, 0, and 2 positives. Okay? So for like today, something really simple is -2, -1, 0, 1, 2. Okay? If I plug in, I'm just going to make a chart, x, y, -2, -1, 0, 1, 2, okay? Now we're gonna do the math. If I plug -2 into here, I get, I would have something like this, -2 times -2 minus 1, right? -2 times -2 is, 4 minus 1 is. If I plug in a -1, -2 times -1 is 2, 2 minus 1 is. If I plug in a 0, -2 times 0 is 0 minus 1. If I plug in a 1, -2 times a positive 1 is -2, and then -2 minus 1 is -3. You're fine. -2 times positive 2, -4, -4 minus 1 is, okay, -5. Here's the deal. If you just set this up once on your homework and then just erase this spot wherever the x is, I'm fine with that. If you need to write it out every time, do it. Okay, it's kind of on you. Now, what's step 2 for graphing this? those points. -2, +3, right? -1, 1, 0, -1, 1, -3, and 2, -5. Boom. Now what do I have to do from there? Connect the dots, or plain connect 4. I'm gonna pretend that this is perfect like I said. Beautiful. Okay, and that matches because my slope shows that's a negative, so I should slope down like this. And my y-intercept is -1, so I graphed it perfectly. Awesome. Okay, linear functions, okay? Y equals -2x minus 1 in the example we just did is a linear function. Why is it a linear function? Because it's a line, because it's in y equals mx plus b form, it's a line. Okay, it's a linear function. Because it can be written in the form y equals mx plus b. Pretty simple. Where b are the constants, the graph of the linear function's a line. By renaming y, okay, sometimes you're gonna see this in your book. Do you see how right here it says by renaming y as f of x? Right here. Okay. So sometimes your equation might look like this in your book. Y, f of x equals -2x minus 1. This and this are the same thing. What it is saying is the function of x depends on what gets put in there, which is what happens when we have a y there, right? Our y depends on our x. Okay, it's just another way of wording it. You're going to turn a lot of things into what's called function notation this year, or function form, okay? That's just how they write function form. It's the same thing. You can replace a y right there and solve it the same way, okay? Don't get confused. Pretty simple. So it's read the value of f at x, or simply f of x. And it identifies x as the independent variable. So whatever inside that parentheses tells me that's what's independent. Okay? Now, tell whether the function is linear, then evaluate the function. Okay? We should be able to tell this without graphing these. Is this a linear function? Function f of x equals -x squared minus 2x plus 7. Why do you say no, Elle? Because there's an x squared. Okay? A linear function only has an x in it. Does not have a squared, does not have a cubed. It has to have an x in it. It can't just be a number. So this is not linear. Okay? Nope. Now it still wants us to evaluate when x is -4. So what does that mean I need to do? Put in -4. Now, here's the deal. The way they're going to show this in your book is they're going to write it like this. They're going to put -4 in for that x. You do nothing with that -4 when it's on the function side. Basically, it's telling me when I plug in -4, I get this answer out. Okay? That's what it's telling me. So I'm going to plug in my -4, and I'm going to do basic algebra. We know how to do basic algebra, right? What is -4 squared?
That's not
16. And then I have 16 times the negative, right? So I get -16. And then what's -2 and -4?
8.
There we go. And then 7. So what is -16 plus 8 plus 7?
-1.
-1. And the way we write this answer is we say f of -4 equals 1. So when I plug in a -4, I get a -1 out. My x is -4, my y is -1. It shows me what I'm graphing. Okay? I do nothing with that -4 on that side. Understood? It's just there to be pretty. Now, is this a function? G of x equals 5x plus 8. You think it's a function? It's in y equals mx plus b form, right? Okay, it's a function. So now we have to solve. G of -4 equals 5 times -4 plus 8. What is 5 times -4? -20. What is -20 plus 8? So G of -4 equals -12. When I plug in -4 in this equation, I get -12 out. Can you handle that? We doing good so far? Okay, last slide.
Ms. Peters?
Yes, sir.
I have a question on
Okay, go back. What?
Why did you say that was not linear again?
This one?
Yeah,
Because it has a square.
so anything that has a square can be.
Yeah, the only things that are functions are anything that could be transferred into y equals mx plus b form. It has one x.
Okay,
So it has to have an x, but it can't have a squared, it can't have a cubed, it can't have anything like that.
all right.
Okay? Okay. A diver. Let's see if I can move this over just a tad so we can read. A diver propulsion, is that what you said, vehicle? A DPV, descends to a depth of 130 feet. The pressure P in atmospheres on the diver is given by P of D. So what is the dependent thing right now? Ooh. P. D is my independent variable, okay? Because D is in the parentheses, it's my independent variable, it's my x, okay? So where D is the depth in feet. Okay, so the formula is P of D equals 1 plus 0.03 D, where D is the depth in feet. Graph the function and determine a reasonable domain and range. What is the pressure on the diver at the depth of 33 feet? Okay, so if I graph this, what do I have to do first to graph it? Chart. I just have to plug numbers in, right, for feet, okay? Now, are you going to, when you plug numbers in for this, for feet, we are diving, yes? Yes. Yes. So we're just gonna plug in, but we're not gonna plug in like negative numbers because we know we're diving and we're going down. Okay, we wanna know what the pressure is. Now, we can choose to plug in pretty much any type of number we want to plug in, so it doesn't matter. I don't know. Plug in like 2 and 4 and graph it. Okay, we can do that later. We don't have to do that part right now. You guys can do that, I know you can. And then we need to determine domain and range. Let's talk domain and range on this. Okay? Domain and range means how far I travel on the x-axis, how far I travel on the y-axis, correct? Okay. What do you think my domain and range would look like in this case? What would be my minimum value of depth we could go? No. What would be my minimum thing I could plug in for depth? Not 1. 0. I could plug 0 in, right? I'm not gonna go below 0, but I could plug 0 in for feet, right? You can go 0 feet. Just stay, but I can't go negative feet, correct? Okay, so in this case, my domain, okay, because D is my x in this case, yes? D equals x, if that's how we're thinking, and x equals domain, right? Okay, I can't go below 0 when I plug it in. Now, here's the deal. I need to actually plug in that 0. Do you get what I'm saying here? Because I have to figure out what I get out when I plug that 0 in. So if I say 1 plus 0.03 times 0, what do you end up getting out of that equation? 1. That equals 1, right? Okay, so 1 foot, or 1 part of pressure is as far as I can go. So 1 is less than or equal to my pressure. My pressure is going to be less than or equal to something, okay? I gotta figure that out. Because there has to be a cutoff, right, for my maximum value, okay? My minimum value is 1. My maximum value, we gotta figure out what that is, okay? Okay, my minimum value I can plug in as 0, but when I plug 0 into the equation, I get an output of 1. Okay? So that's what my minimum is 1 because I'm going off of my outputs. Okay? So let's think about this. If we graph this, okay, we could find out that if we plug in 33 feet, what is the pressure on the diver at the depth of 33 feet? Let's figure out what that is. If I plug 33 into this, okay, 1 plus 0.03 times 33, what do I get out? What is 33 times 0.3? You can figure it out. good.
Just do it in my head.
What do you do? And then you have to do what to that point 99? Add one to it. Add one to it. Okay, then.
I should go to Q1 for that.
T1 from that. So you get 10.9, is that what you're, is that what it is? 10.9? Ellie, you look at me like I'm crazy. I get 10.9 at that, okay. So that's pretty simple. That's like not going that far.
10.9.
Mm.
1.9.
It's 1.9.
1.99.
It's 1.9.
It's 1.99. 1.9. Okay, so I get 1.99. So you see how it's really not going that in depth yet, right? So we gotta figure out what that cutoff is, which means you have to play with numbers. Okay, there is no like quick route to this, you just have to play with numbers. So we have to think a little bit. This is a decimal of 0.03, right? And when we took 0.03 and multiplied it by 33, you end up getting 0.99, right? So what happens if I take 0.03 and multiply it by like 130 or 100 and something, you get what I'm saying? Then I end up getting 3.9, and if I add the 1 to it, I get 4.9, right? Okay. And you can't have a pressure higher than that, really. So if I plug in 130 to this, okay, I'm gonna get 4.9. So I'm gonna put 4.9 here. And the reason I'm doing that is because it says a diver using a diver descends to a depth of 130 feet. That's where I got 130 from, because that's how far he's going down. So my domain and my range comes out to be off of those numbers, starting from 0 and going to 130. Okay, I started from the starting point and went to where he ended. Okay, so I get this domain that 0 is less than or equal to D, and D is less than or equal to 130. So if I take my inputs, these were my inputs, right? I start here, I end here. This makes my domain. My range is what happens when I plugged that in and that in. Does that make sense? So I got my domain from my start of 0 feet to my depth of 130 feet. Okay, gave it to me in the problem. And I got my range from plugging those numbers in and getting outputs. Makes sense, Jackie? I saw you go, oh. Okay, so range is my y-axis in this case. Domain is my x-axis in this case. And it worked out because they gave us a starting and an ending point, so it was easy to find those ranges. Okay, so my domain can be anywhere from 0 being less than or equal to my depth, and my depth being less than or equal to 130 feet, because that's how far I went. And then my range is 1 is less than or equal to my pressure, and my pressure is less than or equal to 4.9. Okay? That is the end of what we're doing. So, your homework is up here already. And I think I put it in Power School already, but I gotta double check.